Hi there, future PEs. This is Wasim Asgar. I'm a licensed professional engineer in the US and Canada. I've authored several books on the topic of FE electrical and PE power, and I also run popular exam preparation programs for both FE electrical and computer, as well as a PE power exam prep. In this video, we are going to tackle the delta and the Y configuration for three-phase power systems. The square root 3 and 30 degrees for delta and Y configuration, the line quantities and the phase quantities, and how to use the formulas properly remains one of the trickiest part of power systems, which is section number 10 on FE electrical and computer exam preparation. It is one of the big 5 topics, the fourth one out of the big 5: math, circuits, electronics, power, and digital systems. And these topics are important not only because they are heavy hitters on the exam, roughly each one of them is about 10% of the exam by weightage, but power systems in particular has an outsized impact because it carries over 100% to P power. In this video, you're going to see me explaining the questions using first principles, and I'm going to be helping my students understand the core fundamental concepts behind these tricky problems. If you're new to this channel, I would really appreciate if you could like this video and subscribe to the channel, and feel free to share your thoughts in the comment sections of this video. So without further ado, let's dive into the content right away. Another question on delta Y transformation. I think this was a question, Kristen, that you were referring to. I was not able to follow the quick explanation in the presentation. I don't think it's really quick. It was actually quite detailed in my opinion, but at least in the live training portion. In the on-demand, I agree. I sort of skimmed through it, presented the formula, but in the live training, it was very, very detailed. If I'm not mistaken, I think I derived it as well. I cannot find it in the NCS handbook. So it's not directly given, it's indirectly given. So I was hoping maybe you could go over how to arrive at it, this formula, because I don't know the explanation in the lecture. This is given impedance transformation. So if you are given a delta impedance, you can convert that into a Y impedance, right? And vice versa. What's not given is a source and the load transformation, right? So the superscripts that are missing over here is that this is the delta line voltage, and I'm converting that into a Y phase voltage, right? So a picture is equal to 1,000 words. So let's start with the picture. So this is my delta network on the top, correct? And I want to convert that into a Y network at the bottom. All right, guys. Okay. So this is the line voltage that is appearing on the delta between the terminals. Okay. So what I'm saying is that whether this is 480, whether this is 600, whether this is 15 kV, 13 kV, 69 kV, okay, whatever voltage this is, I'm going to take that voltage, the line to line voltage of a delta. When I divide it by square root 3 and I reduce the angle, so let's say this has an angle of theta V. When I pull this angle back by 30 degrees, and that is done by showing this 30 degrees in the denominator. Okay. When I do this, what I will be able to arrive at, what I'll be able to achieve will be the line to neutral voltage for an equivalent Y network. So when I say that this is the phase Y voltage, then that is basically what I'm referring to is the voltage between here and here. Okay. All right. That's basically what I'm implying. Now, how does it make sense? What is actually happening during a delta Y transformation? I think that is probably the underlying question. It causes a little bit of confusion that what exactly are we doing over here, right? Are we going out in the field and changing the wiring? I think I answered that in the live training already. Or this is just, mathematic manipulation to make our calculations easier. It's the latter. But how does it work? Well, the fact of the matter is that when you look at the line quantities, and I think I emphasize that in most of the formulas that we deal with, we typically default to the line quantities for voltage and current. So when I look at it as a black box, right, I basically see just the lines sticking out, right? Okay, correct? Outside this black box, I just have these lines that are sticking out, correct? Now, within this black box, if I convert this into a y, because it makes my calculations easier, as long as the line voltage and the line current is not changing, I don't care, right? So when I do this transformation, basically for calculation purposes, I'm coming up with the equivalent Y phase voltage. As far as for the terminals that are sticking out and the line voltage and the line current that is appearing over there, it remains the same. And the closest example I can give you is that of a messy circuit containing a spaghetti of resistors, voltage sources, current sources, parallel series arrangements. And we take this and reduce it to one voltage source, one current source, which he did a couple of weeks ago. And then we call it Thevenin equivalent. As far as these terminals are concerned, this one resistor and one voltage source is giving me the same effect as the spaghetti of resistors, current sources, voltage sources in series parallel. Okay. So to the load side, these line quantities, the line to line is still going to be 480. Whether you look at line to line in Y or whether you look at line to line in delta. The line current that is flowing is still going to be the same. It's just the phase quantities change, and they make a lot of difference because when we have a Y-Y network, what is the biggest advantage? Why do we love Y-Y? Because we can apply the Ohm's law directly on a per phase basis. That's why. Okay. So Y networks. So is it clear now, Kristen? Does it make sense? Did you get a chance to go through this derivation in the live training after you asked the question? And I would recommend, guys, if you can ideally, I know that sometimes you're in rush and you want to capture your thoughts and whatnot. I would suggest that, in majority of the cases, most of your questions are going to be answered, if not in the on-demand, then definitely in the live training, because it's a lot more immersive, right? So if possible, try and hold on to your questions until you get to the live class. Watch the live training, attend it, and then basically you're going to see that 90% of the cases it will be addressed. So Y networks are easier to solve as compared to delta networks because of the fact that when we have a Y-Y network, right? When we have a Y-Y network, we are able to apply Ohm's law directly. Whenever possible, convert the load and the source both to Y. NCSFE reference handbook does not contain much information about delta, phase, and line relationships that we saw earlier. Okay, so please keep this in mind. If you like this video, then please don't forget to subscribe to this channel. Feel free to ask me any questions in the comment section of this video below. You can find tons of success stories of my FE Electrical and PE Power students over here. And if you want to learn more about preparation of FE Electrical and Computer exam and the PE Power exam, then check out these playlists over here. Thanks for watching, and I'll see you soon in the next video.